Dear friends and students, welcome back to my YouTube channel. Today I am discussing the some important ninth class science chapter number 9 exercise question answers, that is force and laws of motion. ಸ್ನೇಹಿತರೆ, ಇವತ್ತಿನ 9ನೇ ತರಗತಿಯ ಮೊದಲು ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ವಿಜ್ಞಾನ ತರಗತಿಗೆ ಸ್ವಾಗತ. ಈ ಒಂದು ತರಗತಿಯಲ್ಲಿ ಚಾಪ್ಟರ್ ನಂಬರ್ 9 ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ಲಾಸ್ ಆಫ್ ಮೋಷನ್ ಈ ಘಟಕಕ್ಕೆ ಸಂಬಂಧಿಸಿದಂತೆ ಎಕ್ಸಸೈಜಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಕ್ವಶನ್ಸ್ ಆನ್ಸರನ್ನು ಚರ್ಚೆ ಮಾಡೋಣ. ಸ್ನೇಹಿತರೆ, ಇದುವರೆಗೆ ತಾವು ನನ್ನ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗದಿದ್ದರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ, ಲೈಕ್ ಮಾಡಿ, ಫ್ರೆಂಡ್ಸ್ಗೆ ಶೇರ್ ಮಾಡಿ. ನಾವು ಮಾಡಿರ್ತಕ್ಕಂಥ ಎಲ್ಲ ವಿಡಿಯೋಗಳನ್ನ ತಾವು ವೀಕ್ಷಣೆ ಮಾಡಬೇಕಾದ್ರೆ ತಪ್ಪದೆ ಪಕ್ಕದಲ್ಲಿರ್ತಕ್ಕಂಥ ಬೆಲ್ಲೈಕನ್ ಒತ್ತಿ. ನಿಮಗೆ ನೋಟಿಫೈ ಆಗೋದ ಮೂಲಕ ಎಲ್ಲ ವಿಡಿಯೋಗಳು ದೊರೆತಕ್ಕಂಥದ್ದು. ಈಗ ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ಲಾಸ್ ಆಫ್ ಮೋಷನ್ ಈ ಘಟಕಕ್ಕೆ ಸಂಬಂಧಿಸಿದಂತೆ ಎಕ್ಸಸೈಜಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಪ್ರಶ್ನಾವಳಿಗಳನ್ನ ಚರ್ಚೆ ಮಾಡೋಣ. ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ಲಾಸ್ ಆಫ್ ಮೋಷನ್ exercise question answers. First question: an object experiences a net zero external unbalanced force. Is the possible for the object to be traveling with a non-zero velocity? If yes, state the conditions that must be placed on the magnitude and direction of velocity. If no, provide a reason. Right answer: according to the Newton's first law of motion, no net force is required to move an object which is moving with a constant velocity. So when an object experiences a net zero external unbalanced force, then it can move with a non-zero velocity. Also, if an object is initially at rest, not net force acts upon it, thus the object may not move at all. Question number 2: when a carpet is beaten with a stick, dust comes out of it. Explain. When a carpet is beaten with a stick, then the fiber of the carpet attain the state of motion while the dust particles remain in rest due to inertia of rest. Therefore, the dust particles fall down. Question number 3: why is it advised to tie any luggage kept on the roof of bus with a rope? Right answer: it is advised to tie any luggage kept on the roof of a bus because when the bus stops suddenly, it readily comes in the state of rest, but the luggage remains in the state of motion. So due to inertia of motion, the luggage will move forward and would fall down from the roof of the bus. If the bus starts suddenly, then bus comes in the state of motion, but luggage remains in the state of rest. Due to inertia of rest, the luggage moves in the backward direction and will fall down. Question number 4: a batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slowed to a stop because the batsman did not hit the ball hard enough. Second, velocity is proportional to the force exerted on the ball. Third, there is a force on the ball opposite the motion. Fourth one, this is no unbalanced force on the ball, so the ball would want to come to rest. Right answers: C is the right answer because the ball slows down to rest as the force of friction acting between the ground and the ball opposes the motion of ball. Question number 5: A truck starts from rest and rolls down a hill with a constant acceleration. It, it travels a distance of 400 meter in 20 seconds. Find its acceleration. Find the force acting on it. If its mass is 7 tons, 1 ton is equal to 1000 kg. Right answers. The solution starts from rest. So initial velocity u is equal to 0, distance d is equal to 400 meter, t is equal to 20 seconds, m is equal to 7 ton. Is converted into kg, 7 into 1000, 700 kg. For second equation of motion, s is equal to ut plus 1 upon 2 at square. Fill the all values in the formula. 400 is equal to 0 into 20 plus 1 upon 2 a into t square 20 square. 400 is equal to 200a is equal to 400 divided by 200, 2 meters per second square. From second law of motion, force acting on the truck F is equal to me, 7000 into 2, 14,000 Newton. It means 1.4 into 10 raised to 4 Newton. Question number 6. A stone of size 1 kg is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meter. What is the force of friction between the stone and the ice? Right answers. Mass of stone is m is equal to 1 kg. Initial velocity u is equal to 20 meter per second. Final velocity v is equal to 0. Therefore, stone comes to rest. Distance covered s is equal to 50 meter. From third equation of motion, v square is equal to v square plus 2as. 0 square is equal to 20 square plus 2 s means 50 value. Pull the value. 100 is equal to 400 minus 400 is equal to minus 4 meter per second square. Here negative sign shows that there is retardation in the motion of stone. Force of friction between stone and ice is equal to force required to stop the stone. F is equal to ma. 1 into minus 4 is equal to minus 4 Newton. Question number 7. A 8000 kg engine pulls a train of 5 wagons each of 2000 kg along the horizontal track. If the engine exerts a force of 40,000 Newton and the truck offers a friction force of 5000 Newton, then calculate net acceleration force. Second question, the acceleration of train. Third question, force of wagon 1 on wagon 2. Right answer. Net accelerating force is equal to force exerted by engine minus frictional force. Here frictional force is subtracted because it is opposes the motion. 40,000 minus 5,000 is equal to 35,000 Newton. 35,000 means 3.5 into 10 to 4 Newton. Second one, for Newton's second law of motion, accelerating force is equal to mass of train into acceleration of train. A is equal to capital F divided by m. Mass of train is equal to mass of engine plus mass of all wagons. 8000 plus 5 into 2000. 8000 plus 5 into 2000 10,000, 10,000, 8,000, 18,000 kg. Acceleration is equal to F divided by A, F divided by M, 35,000 divided by 18,000, 35 into 80, it simplifies the value 1.95 meter per second square. Force of engine 1 on engine 2 is equal to mass of engine into acceleration 800 into 1.95 is equal to 15,600 Newton. 15,600 Newton. Question number 8. An automobile vehicle has a mass of 15,000 kg. What must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? Mass m is equal to 1500 kg. Acceleration a is equal to minus 1.7 meter per second square. For Newton's second law of motion, F is equal to me. M 1500 into minus 1.7, it simplifies value minus 2550 newtons. Question number 9. What is the moment of an object of mass m moving with a velocity v? Option A, mv whole square. Option B, mv. Option C, m square v. Option D, mv, m into v. Right answers. B, D is the right answer because the moment of an object of mass m moving with a velocity v is equal to rho is equal to m into v. Question number 10. Using a horizontal force of 200 Newton, we intend to move a wooden cabinet across a floor at a constant velocity. What is the friction force that will be exerted on the cabinet? Right answer. The cabinet will move across the floor with constant velocity if there is no net external force is applied on it. Here a horizontal force of 200 Newton is applied on the cabinet, so for the net force to be 0, an external force of 200 Newton should be applied on the cabinet of opposite directions. Thus, the frictional force is equal to 200 Newton. Frictional force always acts in the direction of opposite to direction of motion. Question number 11. Two objects each of mass 1.5 kg are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. What will be the velocity of combined object after collision? Right answers. Mass of first object m1 is equal to 1.5 kg. Mass of second object m2 is equal to 1.5 kg. Velocity of first object before collision u1 is equal to 2.5 meter per second. Velocity of second object before collision u2 is equal to minus 2.5 meter per second. Here negative sign is taken because second object is moving in the direction opposite to the direction of motion of first object. Mass of the combined object after collision m is equal to capital M is equal to small m1 plus m2. 1.5 into 1.5, 1.5 plus 1.5, 3 kg. The velocity of combined object after collision be v meter per second. Here there is no external force, so from law of conservation of moment after collision, momentum after collision is equal to momentum before collision. mv is equal to m1 u1 plus m2 u2. 3 into v is equal to 1.5 into 2.5 plus 1.5 minus 2.5 is equal to 0. v is equal to 0. Question number 12. According to the third law of motion, when we push on an object, the object pushes back on us with an equal and opposite force. If the object is a massive truck parked along the roadside, it will probably not move. A student justifies this by answering that the two opposite and equal force cancel to each other. Comment on this logic and explain why the truck does not move. Right answer. The logic given by the student is not correct because two equal and opposite forces cancel to each other only in case if they act on the same body. According to the Newton's third law, action and reaction force always act on two different bodies, so they cannot cancel each other. When a massive truck is pushed, then the truck may not move because force applying is not sufficient to move the truck. Question number 13. A hockey ball of mass 200 gram traveling at 10 meter per second is struck by a hockey stick so as the return is along its original path with a velocity at 5 meter per second. Calculate the change of momentum occurred in the motion after hockey ball by the force applying by the hockey stick. Right answer. Mass of hockey ball is equal to m is equal to 200 gram is converted into kg, 0.2 kg. Initial velocity is equal to 10 meter per second. Final velocity is equal to minus 5 meter per second. Since the final velocity of ball is in the direction opposite to the direction of initial velocity, change in momentum of ball is equal to final velocity momentum minus initial momentum. mv minus mu is equal to small m into bracket v minus u minus 0.2 into bracket minus pi minus 10, 0.2 into minus 15. It simplifies value minus 3 kg meter per second. Question number 14. A bullet of mass 10 gram traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 seconds. Calculate the distance of penetration of a bullet into the block. Also calculate the magnitude of force exerted by wooden block on the bullet. Right answers. Mass of bullet m is equal to 10 gram. 10 divided by 1000, 0.001 kg. Initial velocity u is equal to 150 meter per second. Final velocity v is equal to 0. T is equal to 0.03 seconds. Equation of motion v is equal to u plus at. 0 is equal to 150 plus a into 0.03. A is equal to minus 150 divided by 0.03. Is value simplify the value minus 5000 meter per second square. Magnitude of force applying by the bullet on the block F is equal to ME 0.1 into minus 5000. Question number 15. An object of mass 1 kg traveling in the straight line with a velocity of 10 meter per second collides with and stick to a stationary wooden block of mass 5 kg. Then the both moves off together in the same straight line. Calculate the total moment just before the impact and just after the impact. Also calculate the velocity of combined object. V is equal to 10 divided by 6 is equal to 1.67 meter per second. Mass of object m1 is equal to 1 kg. Velocity u is equal to 10 meter per second. Mass of wooden block m2 is equal to 5 kg. Velocity u is equal to 0. Total moment just before of the impact. Total of the object. Question number 16. An object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. Calculate the initial and final movement of object. Also find the magnitude of force exerted on the object. Right answer. Question number 17. Question number 18. Right answer. Dear students, if you have any doubts in the chapter exercise question answer, please share and subscribe my channel. Thank you.